This video goes through simplifying a cos of x plus b sine of x. And what I mean by simplifying, it means bringing it into one term. And that's really important because it is useful being able to sketch graphs and also solve equations. So we're going to be transforming a cos of x plus b sine of x into the form of r sine x plus or minus alpha, or r cos x plus or minus alpha. Now, if we have it like that, we can see all our translations and transformations. We can see our amplitude. So we can then sketch. Additionally, if we have it in that form, we can also solve. Now, let's start with a sine of x plus b cos of x. We want to write it in the form of r sine x plus alpha. Just choose one. You could write it in the form of r cos x plus alpha if you want. But let's go for r sine x plus alpha. Now that sine of x plus alpha, we can use our sum and difference identities to expand that out. So looking at a formula sheet, I can rewrite sine of x plus alpha as sine of x cos of alpha plus cos of x sine of alpha. And you can see that I've put the r outside the brackets. So I'm just dealing with that sum. Now bring the r back in and I get r sine of x cos of alpha plus r cos of x sine of alpha. Now we're going to equate our coefficients. Now what I mean by that, on the left-hand side, you can see we have this sine x. So that has to match with that sine x. Also, we have cos x on our left-hand side that has to match with the cos x on the right-hand side. So look at what goes with it. So in front of the sine of x, we have a, and with the sine x on the right-hand side, we have r cos alpha. So that means a has to equal r cos of alpha. Looking at our other term, our b cos of x, so now our b has to equal r sine of alpha. So now we have two equations. We have r cos of alpha equals a and r sine of alpha equals b. What we do now is we square and add. So I want to go equation 1 squared plus equation 2 squared. Now what happens there is we get on the left-hand side r squared sine squared of alpha plus r squared cos squared of alpha. If I bring out this common factor of r squared, then I get inside my brackets sine squared alpha plus cos squared alpha. That's a trig identity and it's equal to 1. Okay, and then on the right-hand side, I have a squared plus b squared. So now I have r squared equals a squared plus b squared. Or r equals the square root of a squared plus b squared. Now that will be for when r is greater than 0, because remember I could write r is equal to plus or minus the square root of a squared plus b squared. Now going back to our two equations, now I'm going to divide equation 2 by 1. Now writing it in full, I would have r sine of alpha over r cos of alpha, remembering the r's are going to cancel, so that will leave us with tan alpha. So I haven't shown those steps. And on the right-hand side, we'll have b over a. So these two things are very important. We have tan of alpha equals b over a, and we have r equals the square root of a squared plus b squared. Now, I've summarized these things in the pink box, but don't remember them. You need to remember the process. Okay, do the process. That's what's important. You'll also see down the bottom that I have that my r is equal to square root of a squared plus b squared, and that tan alpha is b over a, remembering that b over a are our coefficients of sine and cos. So coming back to what we start with, you can see where that a and b are. So probably the best option now is to let's do some examples and you'll see how to apply this.